This is 5.7, part 2. We're going to continue on doing one more example of where we graph a quadratic inequality to find the solution. The difference with this problem than the first example that we did was the first example was in vertex form. This quadratic is in standard form. So we have to find a few more pieces before we can quickly graph this quadratic inequality. So make sure you're following along with this example. So step one is we want to graph this quadratic equation. So in standard form, the quadratic equation would be y equals x squared minus 4x minus 5. So we're going to just start picking some pieces out. So let's find the x-intercepts of the graph. So in standard form, to find the x-intercepts of the graph, we're going to set the function equal to 0 and solve for x by factoring. So we're going to use the chart method to factor this. So we say, what are the factors of -5 that add to -4? Well, that is -5 plus 1. So if I were to FOIL that back out, I would get my original quadratic equation. Now I'm going to use the zero product property and set those factors equal to 0. So I get x equals 5 and x equals -1. Those are what we call the zeros of the function, which then will be the x-intercepts for our graph. So the x-intercepts are at 5, 0, and at -1, 0. Next, let's go down and find the vertex of the quadratic equation. This is in standard form, so we showed you a little shortcut earlier in chapter 5. To find the vertex, we take opposite of b over 2a. So this is my a value. My a value is 1. And my b value is -4. So we're going to take opposite of b over 2a. So if you want to write this down here, a equals 1 and b equals -4. This is called the equation for the axis of symmetry. So now let's substitute it in. Negative, and then opposite of b over 2a. So opposite of b is going to turn that to a +4. And then 2 times 1 is 2, which is 2. So this is my x value for my vertex. To find the y value, I substitute this x value into the original equation, original function. So my original equation is y equals x squared minus 4x minus 5. We're going to substitute the x value in. So my equation was give myself some more room there. The original equation was y equals x squared minus 4x minus 5. And I substitute 2 into here and 2 into there to get the y value. So I'm going to substitute into that red equation. So I get 2 squared minus 4 times 2 minus 5. So 2 times 2 is 4. -4 times 2 is -8. And then minus 5. So 4 minus 8 is -4. Minus 5 is -9. That's the y value of your vertex. So the ordered pair for the vertex, which we call the critical point, is 2, -9. We'll find one more piece. Let's find the y-intercept of the parabola. Well, the y-intercept is the c in standard form. So if I go back up to the problem, the c is right here, -5. So then my ordered pair for my y-intercept is 0, -5. Now let's go ahead and graph this parabola in standard form. So let's graph the blue intercepts first, those x-intercepts. So my x-intercepts were at -1 and 5. So I have an x-intercept at 5. So 1, 2, 3, 4, 5. Actually, let's make this I'm going to run out of room. Make this 1, 2, 3, 4, 5. And then my y-intercept is, x-intercept is -1. Okay. The vertex point was at 2, -9. So over 2, down 9. That's also called the minimum point since the parabola opens up. And then my y-intercept is at 0, -5. So now I can graph this parabola. So now I've graphed the parabola, but I still have to find the solution to this inequality. The inequality is y is greater than or equal to x squared minus 4x minus 5. So just like the last example, I want to pick a ordered pair inside the u and a ordered pair outside the u and figure out which one is true. So that's leading us down here to step 2. So just like the last example, I test a point inside and I test a point outside. So outside, I've chosen -3, 0. So let's go ahead and substitute that in and see if it's true or false. So here's my x value and my y value. So 0 is greater than or equal to -3 squared minus 4 times 0 minus 5. Now we reduce it. -3 times -3 is 9. -4 times 0 is 0 minus 5. And then reduce 9 minus 5 is 4. Now read it. Is 0 greater than or equal to 4? No, that's false. Now this other one then should be true, the ordered pair 2, 0. So we substitute 2 and 0 into the inequality. Get rid of that. So 0 is y, 2 is x, 2 times 2 is 4, -4 times 2 is -8, then 4 minus 8 is -4, -4 minus 5 is -9. Is it true that 0 is greater than or equal to -9? Yes, that's true. So the region that we're going to shade is where the ordered pair 2, 0 is, which is inside the inequality, or inside the parabola. Here is 2, 0. So we're going to shade inside the parabola. And that is the solution to this inequality. So this is your assignment for 5.7.